Hello, everyone, and welcome to today's exciting webinar. I'm Tim Stark and the host of today's exciting event. I'm a professor of civil engineering at the University of Illinois and technical director of the Fabricated Geomembrane Institute. This is our 14th webinar of 2020, and the remaining one for 2020 is a live panel discussion on subgrade preparation and CQA procedures with a great number of panelists, which are listed on the last slide today. During today's webinar, we welcome questions and comments, which can be typed into the questions box in the control panel. You may send in your questions at any time during the presentation, and our speaker will address them at the end of today's presentation. The recording of this webinar and a PDF of the slides will be made available on the FGI website after today's presentation. PDH certificates will be sent automatically to all who attend the entire webinar. Okay, it is a great pleasure to introduce today's webinar speaker, which is Dennis Parra, who is the General Manager of Andes in Lima, Peru, and he is also an Associate Professor of Civil Engineering at the National University of Engineering in Lima. Dennis has over 30 years of experience in mining projects related to heap leach pads, tailings dams, process ponds, water dams, and other mining facilities in Peru, Chile, Brazil, Argentina, Colombia, Mexico, Bolivia, and Panama. The title of Dennis's webinar today is Geosynthetics in Mining. Dennis, thanks so much for squeezing this webinar into your extremely busy schedule and joining us from Lima, Peru. The webinar controls are yours, Dennis.
Thank you. Good morning in Illinois and good afternoon here in Lima, Peru. First of all, I want to thank Tim Stark for inviting me to this webinar to present my experience in geosynthetic in the mining industry in this part of the world, in South America, and specifically in Peru, where we have a lot of challenge regarding the designing with geosynthetics. This is the content of this presentation. We will talk about the use of different geosynthetic in the mining industry. We will talk also about the mining facilities which use this kind of product. We will talk a little bit about the liner system and geomembrane soil GCL interface interaction, which is very important for the design of some facilities, such as leach pads, for example. Some consideration for the use and installation of geosynthetics in this kind of terrain that usually we have in the Andes, which is very aggressive. And other application of geosynthetics, not so common, but I mean, its application in the mining industry, a summary of all that we will see today. We will start talking about the use of geosynthetic in the mining industry, of course, talking about the geomembrane, which is, very used in the mining industry, mainly as a liner of heap leach pad, permanent leach pad or dynamic leach pad is very used in the mining industry. Also, we use as a interleaf liner for permanent leach pad when we have a low grade ore or when we have a low permeability and we need to put an interleaf, a liner system every single leaf. So we use geomembrane of different kind of quality. Also, a liner for leach ore dam when we have a dynamic or also called on-off leach pad. We have to remove the ore and we have to place that leach ore in a dump and need to be, of course, lined with geomembrane. Also, we use liner in tailings dam. It's not so common, but lately it's become more common to use geomembrane liner in tailings dam. We will show some applications. Also for pond storage, solution, acidic water, fresh water. Also for encapsulation of waste material to mitigate acid drainage. Raincoat system in heap leach pad to avoid the infiltration of the rainwater and also for avoid dilution of a solution. Cover system for mine closure, cover for erosion control, liner of temporary canals or channels, liner for evaporation pond in lithium extraction industry, where they use a huge amount of these kind of products. Also, we have geosynthetic liner, the GCL, which is used very common to see this kind of application in the mining industry as a secondary barrier below the single or double geomembrane liner in ponds, encapsulation of waste rock to mitigate acid drainage, capping system for closure. When we talk about a barrier below the single liner system, basically we are talking about heap leach pads, for example. Geotextiles is another product that is very used in the mining industry as a filter for under drain and collection pipes, which we have to take care of. And also we need to study very well when we use this, because we can have some problem of clogging, which is very common also. But geotextile is used for as a separation layer, or as a protection of GCL or geomembrane in aggressive slope when we use a very heavy geotextile, of a cushion layer for protection of geomembrane, ground stabilization, reinforces the wall erosion control, or geotubes for tailing or sludge contention, which we have several applications in the last few years. GeoNet or geocomposite is very used also as a leak detection for a recovery system, as a drainage below GCL in steep slope, protection of GCL, and also HDPE pipes for underwater collection, for leachate collection, for leak detection monitoring. And another application that we have for geosynthetics is, for example, GeoGrid in soil stabilization, in slope reinforcement and stabilization, mechanically reinforced wall earthwork. Also, we use GeoWebs as all these applications that we can see here. Consideration for the use of geosynthetic in mining, we need to consider that the mining projects are usually far from populated center. Then logistics and shipping of the material must be taken into account, which imply cost and time. Some technical specification must be met and verified before shipping the materials to the site. That's very important when we have, for example, geomembrane. In this case, for example, the MQA, the manufacturing quality assurance, is a good option to avoid non-conformance and construction delays. When we have the product that is not meeting the specification, it's better to certify and verify the quality during the manufacturing. And a special consideration, of course, needs to be taken in the design and construction when we have regions of, for example, high seismicity, high precipitation, high altitude, or aggressive terrain. All these factors are appearing in countries like my country, like Peru, when we have, I mean, all these factors that we have to deal when we design any kind of facilities, but mainly when we use geosynthetics. In the mining facilities, we have, for example, waste dumps, which, of course, we know that they are facilities for storage non-economic material for the mine. The material to be placed are basically granular and often very large size. If this material has potential for acid drainage or metal leaching, then soil liner or geosynthetic is needed. Waste dump might require some seepage or acid water collection system. We have here, for example, a photo showing a waste dump with a waste rock material and a geomembrane liner. And in this case in particular, this waste rock has had a high content of pyrite, then very high potential for acid drainage, then we need to use geomembrane. It's not so common for waste dump, but in some cases we had to use. tailings dams, they are facilities for tailings storage of the milling process. Tailings can be discharged in pulp, it's a thickened paste, or placed as cake, as a filter. If this material has potential for acid drainage, even as a cake or filter, some cases membrane liner is needed. But also in some other cases, when an aspect of perceptions and social environmental commitment, in that case, it's also membrane liner is also an option, because it's easier to get approvals from the regulators. We will see here some examples in South America. For example, here we have a downstream tailings dam with lining impoundment to this elevation. Okay, we can see here the impoundment site. Higher elevation, it is really very high. We have here a lined facility for tailings storage. This is a center line dam with a liner of all the impoundment, a very high altitude. Another high altitude application, very large facility with membrane liner. It is a project in Argentina, and also we don't have not so much, it's not so high, but of course, in some cases, we need to use geomembrane liner for impermeabilization. Heap leach pad. As we can conclude after decades of this kind of facility has been used in the mining industry, that they are probably the single biggest user of geosynthetic in the mining industry, and also compared with other industries. These facilities are used for stacking fresh ore leached with solution for metal recovery, such as gold, silver, copper, nickel, uranium. In South America, we have, in general, Latin America, we have heap leach pads for gold, for silver, for copper. We don't have just for nickel. We don't have steel for uranium. Impermeabilization of leach pad base is needed, of course. Geomembrane integrity due to the heap height must be evaluated, of course, because we can go as high as 200-meter heap. And the leach solution is collected through drainage pipes at the base of the heap. The solution is conveyed to ponds and then pumped to the process plant where we can extract the metal. We have some example here of heap leach pad in South America, in this case to 3,600-meter altitude. Another facility in the Andes. Another one in the south of Peru, close to Chile. This is in the north. Also, we have the backside of the leach pad. We have very large area of a gold operation. It is a copper operation in also high altitude. And also, I wanted to show this one because this could be or must be the highest altitude leach pad in the world, 5,100 meters. I was commenting with Tim that the first time that I watched the project to start the design, it's very hard even to think at that condition. It's very hard to think. It should be harder when we have to work for construct this facility, and of course for the installation of the geosynthetics. Ponds, they are facility for storage of fresh water, acid water, leach solution, tailings. In cases of fresh water or no contaminant liquids, a single geomembrane liner is enough, sufficient. When the liquid is contaminant, then we need to install a double geomembrane liner with a leak detection between the two geomembranes. And the leaks are collected by pipes and pumping back into the pond. We have here some photos of mining operation when in this case, we have a PLS, a pregnant leach solution pond, and a stormwater pond, also called emergency pond. In this case, we have PLS and stormwater ponds. And in this case, we have 3 ponds. When we need some intermediate solution, intermediate leach solution, we need an extra pond to manage the solution to be pumped to the leach pad. About the liner system and geomembrane interface, we have the single composite liner system, and we can show here the foundation, soil, or rock, okay? The prepared foundation. Over the foundation, we need to place a low permeability soil or even GCL. We will show some cases of some criteria where when we use low permeability soil or when we use GCL, right? This is the requirement of the permeability for clayey sand or clayey gravel, which is the low permeability soil. Over this soil liner, we install the geomembrane. Usually we install 1.5 or 2 millimeter HDPE or LDPE. They are very common in the mining industry. And all this stuff we call the liner system. And over the geomembrane, we install, we place the overliner, which could be just for drainage or also for protection. As a protection material, if we have, for example, raw ore, which large size particles can damage the liner, so we need an overliner, in this case, for protection. This is the size usually that is used for the overliner. On the top of the overliner, we place the operating lift. What happens when we have a double composite liner system? Again, the foundation soil, the low permeability soil or GCL, the secondary geomembrane, which is usually to use 1.5 or 2 millimeter HDPE. It's very common to use high density polyethylene. Then we use the geonet or geocomposite. 5 millimeter is enough. We can have thicker in some cases. In some cases, we use geonet, and if the pond is very high, so we need an extra protection with geocomposite, which is the geonet plus two geotextile. The primary geomembrane, also the same thickness and quality material. And all this stuff, that's what we call the liner system. This is a very good example of we are talking about the overliner material, the geomembrane, and the soil liner, the clayey or the clay sandy or clay gravel soil. And something that we need to take into account is that the main failure mechanism of a leach pad is through the interface. It's for the reason that we need to study and test these two interfaces, geomembranes and soil liner, and also the geomembrane and overliner. And that's why usually in the past was enough to do testing between the geomembrane and soil liner, because the asperity height was in the order of 0.25 millimeter. But now the industry is using a higher asperity height, which is 0.4 as minimum. In these cases, in some cases, the overliner and the smooth geomembrane become the weaker interface. So now we need to test these two interfaces. Here we have an example of a heap leach pad with a soil liner in this kind of slopes where we can place soil liner. And also we have GCL in a steeper slope, in some cases even vertical, okay? Then we have soil liner and we have GCL, and when we place the geomembrane on top, we are creating this interface. Yeah, and the other interface is the interaction between the geomembrane and the ore, in this case, the active leaf of the leach pad. Some geotechnical laboratory testing for soil geosynthetics materials. The most common device that we use is the large-scale direct shear for testing. In one case, the geomembrane and the top, the soil liner or the overliner. We can see here as the sample remains after the testing with about 75 millimeter separation, which is the maximum displacement that can happen in this kind of testing device. This is the equipment, the large-scale direct shear installed in the Andes laboratory in Lima. This is the results. In this case, for example, we have 4 loads, different loads that we can apply here 3,000 kPa, but in this case, usually the shear box is 30 centimeters. This is the maximum size. But when we need to apply high loads or higher loads, so it's better to use a smaller shear box. But in this case, for example, for this load, we use both boxes and we compare. In this case, the comparison of the 30 centimeter box is the same as the 21, of the 20 centimeter one. Then we can rely in the results for higher loads. This is the typical normal stress and shear stress in this equipment. In this case, we have the peak envelope, the peak shear strain envelope. Here we have the post-peak, and it's very common to see a nonlinear envelope. Okay, and this is that we need to use for the design. If we have to try, we have to go as to the maximum loss, which is calculated based on the weight of the hip, in order to have this envelope complete. Also, the other geotechnical testing that we usually have is the human brain puncture test. In this case, we are using the same permeability equipment, because I mean we can use in square, or we can use in round, in circular material. That's not a problem. That we need to do is place the soil liner in the bottom, place the human brain, and then the overliner, and place the load, the maximum load, in stages as the liner would be subjected in the field. Here, for example, we have a result of this integrity of puncture test. In this case, we have a 1.5 single side texture LLDP membrane. We have the geosynthetic, in this case it's human brain, and the overliner is this kind of soil. This is about 110 meter hip. It is 2000 kPa of load, and you can see here some yielding, some minor damage that can be accepted. But in this case, for example, we have also the same configuration. It's another project. We have a maximum load of 3000 kPa. It is about 170 meter hip. And you can see here is a very a lot of puncture, a lot of damage, a lot of yielding. And even if there is not a hole, this kind of results cannot be accepted. A future trend in interface testing is the cyclic direct shear. In this case, the result corresponds to GCL. Professor Fox, formerly University of Pennsylvania, and they did a lot of work developing this kind of equipment, which is very similar to the cyclic testing that we have for soils. But here we can see this theoretic loop. Of course, we cannot have here a shear strain. It's not possible in this kind of equipment, this displacement. And in the theoretic loop, we basically determine the rigidity, the second shear, the stiffness, and of course the damping. Based on this parameter, we can apply, we can use those parameters for dynamic analysis, including interface liner. I don't see so many research and also application of this kind of parameters for dynamic analysis of this kind of facility, which use geomembrane and generate interfaces, but I think and I hope it could be a future trend. Regarding the consideration for the use and installation of geosynthetic, we will present my experience, the experience of our equipment here in Peru and in South America about all this construction process that is usually for the geosynthetics facility construction. The first of all is the under-drain installation. The under-drain system is used for groundwater collection, for avoiding the damage of the liner. You can see here trenches. We can see here the geotextile, the pipe, and this is typical. It's typical to use a trench with different diameter depending on the collection area of HDPE perforated pipes, which is backfilled with gravel. This is a typical trench for under drain installation. We have to take care when we use geotextile. I talked this at the beginning, but in many cases I saw a lot of cases of clogging of the geotextile. So we need to take care. If we use, as in this case, for separation only, I mean, there is not a problem. But when we try to rub the trench, so this can generate a problem, because if the geotextile clogs, then it will become impermeable. So the under drain system is not meeting his function. For example, in village facility or pond, also this under drain is used for detect leakage through the geomembrane. And all these systems need to report to an under drain pond where we can install a monitoring system. Some criteria for selection soil liner or GCL, some general recommendation. In South America in the past, the soil liner was placed on slope up to 1.5 to 1. In some cases, even steeper, 1 to 1. But in this case, the roller cannot work alone. Need to use a winch system with a wire to pull the roller and compact on the slope. Then in the past, we have had a lot of safety issues that need to be addressed for performing this kind of work. Currently, that is not allowed anymore. Here we can see the roller working in a very steep slope. We see here this equipment. We have here a pulley. We have here a rope, and the rope is pulling by the truck. Then the roller can go up and also can go back, but also by using this winch system. Currently, many projects with safety restriction, the soil liner must be placed and compacted on a slope less than 2.5 to 1, which means 2 horizontal and 1 vertical, or even 2.5 to 1, which the soil liner can be compacted within any winch system, basically for safety restrictions. However, for a slope steeper than those above, then as we can see here, in this case, almost vertical slope, GCL must be used. As we can see here, in the benches for generating some access. So we generate very steep slopes, then we need to use GCL, and in not so steep slope, we can use still the soil line. Okay. What happens in aggressive slope? Okay, we need to protect the geosynthetics in this kind of aggressive slope. When we have rocky surfaces with sharp edges or cavities, then to avoid puncture and deformation, we need to place some protection. The protection of these irregular surfaces can be by using heavy geotextile, as we can see here in the photo, We can also use geocomposite, which is the geonet in the middle of two geotextiles. Here the slope is not so aggressive, but in some cases we have some rocky areas, then geocomposite is a very good option. Electro-welded wire mesh, I don't know if it can be seen, but maybe if I put here, you can see the electro-welded mesh when we have a very rocky with sharp edges, then this has been used in some of the projects. Or also we can use shotcrete, mortar, soil cement, but we need to protect geosynthetics. Some technical aspects for using GCL. The GCL usually is used when we have restriction to get the soil liner from a borrow source, for example, when it's far from the construction site, or where the soil liner presents high moisture content, so GCL is an option. In this case, for example, the GCL can be used in this area where we have a steep slopes, but in this particular project, it was decided to use in the whole area because we have restriction for getting soil liner. Then when we have, for example, a slope up to 3:1, so we can use unreinforced GCL, but when we have a steeper slope, needle punch GCL need to be used, as in this case, vertical slope, needle punch is the better option. Of course, we have to verify the stability due to the GCL low shear strength. And also we have to take care with the overlap as a minimum 25 centimeter in flat areas, or 45 or even 50 centimeters in slope to avoid separation by shrinkage, we can see here, which it could be a very big problem if that happens, and can happen at least in a couple of projects that I know. Also, it's very common after installation. In this case, was just right away the installation, but after installation and the leach pad operating, the GCL can be hydrated. Then, in this condition, must be tested because, of course, the shear strength reduce even more. About the geomembrane liner, for mining application, waste dump, or basically or mainly for heap leach pad, LLDP is highly recommended because of several reasons. For example, this material presents high flexibility and elongation. Also, the shear strength is improved, and also present a better puncture behavior. We can see here a typical detail of a single liner geomembrane. It's recommended to use single side texture geomembrane with the texture side in contact with the soil liner or GCL in order to increase the shear strength in that side. The geomembrane usually is coming with in rolls of 120 or 150 length, but we can request longer rolls directly during the manufacturing process. This is also something that can help when we don't have enough shear strength, because we have a soil liner with for example, high clay content, and we have a low shear strength. So we can create a friction layer by using coarse sand, spreading with personnel, yes, with workers, spreading at least few centimeters of this material, create this friction layer, increasing the shear strength of the interface. Temporary and permanent anchor, of course, are required, but we need to take into account the recommendation of Rick Thiel. He studied landslide during an earthquake, and recommending to place non-woven geotextile in order to avoid the stress of the geomembrane. Also, a practical rule for thickness is to use 1.5 for hip up to 100 meters and 2 millimeters for higher hips. We can use 2.5, yes, but we will show you later that it is not recommended. But at the end, the final thickness that we have to design depend on the puncture test. As if the puncture test with the thickness that we recommend and use show this kind of minor yielding, that's fine. But we have a lot of yielding and in some cases holes detecting by the vacuum test. This is not passing, so we need to do something else. Then the geomembrane installation versus the slope, we can do some summary. We have to prepare the ground by liner compaction. We have to prepare when we have a very steep or vertical slope, as in this case. We have to protect the geosynthetics in aggressive slopes. We have to install GCL in this kind of steep slope. We have to install the geomembrane and welding in very hard and complicated conditions. We have to inspect the geomembrane after installation, and here we can see the full and complete installation in this case of Parra leach pad. It was one of the first leach pad in Peru about in the year of 1996. In some cases also we need to protect the geomembrane under loads. When this is needed, when the heat, for example, is more than about 120 meters, we need protections against high loads in order to avoid punctures. In this volumetric or configuration of a leach pad, we have the maximum height and the maximum capacity that the heap leach pad can have. And we define the area where the leach pad will have 100 meter height. So in this area, we need to do something. And what we can do? We can use a thicker geomembrane, but in fact, it's not necessary. But instead, at least 270 grams per square meter or heavier non-woven geotextile must be used instead of using a thicker geomembrane. But of course, as we are introducing a new interface, we need to do a stability verification because, of course, there is a reduction of the shear strength of the geotextile geomembrane interface. So we need to place in some specific area of the leach pad, and for example, not close to the top. For the leach pad collection, we use this kind of pipes. This is the collection system is for leach solution, for seepage flow through the waste rocks, for example, of acid water, of water with metal content. Dual wall perforated HDPE pipe, smooth inside, corrugated outside are used. Diameter of 100, 200, 300, or 450 millimeter is commonly used. But in some cases, 600 millimeters have been used. This is the typical detail of where the pipe is placed on the geomembrane and gravel around, as we can see here. Of course, when we have, high heap leach pads or dams, and more than about 120 meters according to our experience, then pipe protection is required for avoid damage by deflection and crashing. Also, we need to take into account that deflection of 15 to 20% is accepted. Okay, here we can see some crashing of the pipe by inspecting inside. In important projects, it's recommended to do pipe deflection tests. Okay, but they are of course very expensive, so we need to select in which cases we need to do this kind of deflection test. If the pipe can still convey the flow and perform as required, its appearance is not relevant. As we talked before, 15 to 20% is accepted. The pipes, in these cases, when we need to protect them of the high loads, need to be placed in trenches, as the figure is showing, and backfilled with drainage gravel to provide confinement and reduce deflation, because the load is taken by the gravel instead of directly by the pipes. No, we can see here some examples of the trenches and pipes, and of course geotextile that is needed to protect not the pipe but the geomembrane inside the trench. Overliner. The overliner is used to protect the geomembrane from damage caused by falling material greater than 1.5 inches of 35 millimeters and to provide drainage. The overliner maximum size is typically 1.5 inches. Okay, and we can see there in the photos, it's granular material. Excuse me. The thickness is typically 0.5 meter, or in some cases a bit more. Also, we need access of at least 1.5 or 2 meter thickness to hold the overliner inside the lined area. And also for spreading, we need to use D6 type track dozer or smaller equipment for spread the overliner. Well, here, for example, we can see the whole area of the new expansion of this heap leach pad with the overliner, which is the work is being completed in this area, where also need to be placed with membrane, with the overliner. In this case, we have an ore with maximum size of about 6 millimeters. Then overliner is needed in this case. In some cases, we have also interleaf liner operation. This is a very typical copper operation when ore permeability is very low. Then we need an interleaf liner as an option for permanent leach pad. Where here we can see some photos in the copper industry in Chile, when we have this large equipment for spreading the ore, mechanized ore conveying. Okay. In this case, for example, is a very typical photo of Manto Verde operation in Chile, where we have several crews installing the geomembrane below the area where the stacking is working. Otherwise, we will need a lot of overliner if this big and heavy equipment need to be working over the geomembrane. So, and that is very expensive in some cases. Okay? For this kind of equipment, maybe we will need 1 meter of a liner. Then one way to avoid this cost is working in this way. Also, we need to install the collection system, which is single wall pipes, very flexible one coming in this way. So we just need to spread and to create this collection system, and we need to do this every single lift. That's called the interleaf liner operation. Okay. About the raincoat in heap leach pad, They are used to prevent water from entering into the heap or damp in regions of high rainfall events. They are usually mainly for gold and silver heap leach pad. We can see here, for example, an area covered with a raincoat, okay, for avoiding the solution dilution, which make that the metal recovery is more efficient and water treatment cost is reduced. In some cases, we have a raincoat system installed in 80%, 90%, or 100% of the area of the leach pad in very heavy precipitation regions. But in dry regions, also we can use raincoats to cover and prevent evaporation and reduce the water demand. It's also, in some cases, have been used, but they are mainly used for rainy areas. In ponds, in this case, we can use single liner for stormwater ponds. In some cases of some environmental commitment, double liner has been used a lot at this in Peru. The double liner for pond, PLS pond, that need to be double liner. Here we have a detail with the soil liner, or could be also GCL, the secondary geomembrane, the primary geomembrane, and in the middle we have the geonet for leak detection. 1.5 or 2 millimeter smooth HDPE. Texture HDPE can be used, which facilitate the when we walk for inspection, for example, is very complicated and also dangerous to walk in a smooth membrane. But if we put a texture membrane, that help a lot. The geonair or geocomposite for leak detection through the primary geomembrane. And the installation is in this way. As first, we place the geomembrane after the ground preparation. Then the geonet is placed on the top of the secondary geomembrane. Then the primary geomembrane is placed on the top of the geonet, and we have the complete installation and operation of ponds. The leak detection sump is usually installed in the lowest spot of the pond, creating this sump, and where we have this pipe and a small pump inside. So if there is some leakage in the primary geomembrane, it can report to the sump, and we can pump it back to the pond, as we can see here. Other applications, we have, for example, geocell, which is used for road construction, for channel protection, for channel liner, but also for pond liner. Here we have the GeoWeb, and if we put concrete on the top, so we create, as we can see here, a pond, impermeable pond of this kind of material. GeoGrid has been used for, in general, for soil and wall reinforcement, also in the mining industry. Here we can see reinforced wall designed and constructed for a tailings dam raised 4 meters high, okay, which is considered a center line construction. Here we have this GeoGrid for reinforcement. Also is used for this kind of walls, very typical, for example, in crusher facilities. And here we have a reinforced wall constructed for a tailings dam. Also, we have geotubes for mud and tailings containment. This is a facility constructed in Colombia with geotextile, and which is used as a filter to evacuate the water and just remain the mud or tailings, basically tailings. And we can construct in this way also a dike and to create some impoundment. Also, bituminous geomembrane has been used in some cases, not so much in Latin America, but we have some cases in hill beach pad and ponds. They are very heavy and also resistant materials. We can see here a construction equipment coming on the top of the membrane without any problems. Also, this material can tolerate greater material than a normal membrane, up to 3 inches, no problem. No? We can see some installation process and some pond installed in the Andes in Peru. Finally, we can see here the geomembrane in evaporation ponds for the lithium extraction industry. They are huge ponds. I mean, 1,000 hectares of PVC or LDPE geomembrane that is used for evaporation, for extracting salt, and also extract and lithium, which is used for batteries and for electric cars industry, right? As a summary, we can conclude that the GCL and the geomembrane on irregular surfaces must be protected for future using geocomposite, geotextile, or other systems. Suitable criterion must be used for select GCL, use needle punch in slopes, that's something that we explain. For hill beach pad or waste dump, 1.5 or 2 millimeter single site texture LLP geomembrane is generally recommended. For facilities greater than 120 meters high, protection of geomembrane and pipes is needed by using geotextile. Basically, that's the recommendation. Also, this is the state of practice and experience. Raincoat system prevent dilution of solution and reduce treatment water treatment costs. And something also which is very important is that experience of the installer is extremely important to guarantee quality of the geosynthetic installation and, of course, adequate safety conditions. That's the end of my presentation. Thank you very much for attending. Gracias por su atención.
Great, thank you, Dennis. And we have a bunch of questions here. So let me get started. I'm not sure we're going to get through all of them, but here we go. We probably have, I don't know, 30 questions. For heap leach pads, is the geomembrane used any different from the geomembrane used in a municipal solid waste containment facility in the United States? And maybe you're not familiar with that, but
I mean, it's in the industry at the beginning of the heap leach pad technology, the HDPE was used. It was very common because of the flexible geomembrane doesn't have enough resistance for UV attack. Then, when the manufacturer become to improve this quality, particular quality of the flexible geomembrane, then the LDPE become more popular, and now is that usually we have in the industry. And my understanding is that in the state is almost the same.
Yep. What is the minimum thickness? And I think you had that on your last slide. What is the minimum thickness of the geomembrane that is usually specified?
According to my experience, is 1.5 LDPE. We didn't use, thinner geomembrane because the quality control is not so, it's a little complicated. Even for a smaller leach pad up to 40 or 60 meter, 1.5 is the minimum that I suggest.
Okay. Are the CQA procedures similar to those used for municipal solid waste landfills in the U.S.? For example, how do you check the seams on the LDPE with air channel testing, vacuum box?
It's exactly the same. We have channel testing for wedge welding. We have a vacuum box for for patches. I mean, it's exactly the same. We have a, I mean, geomembrane in heap leach pad operation is the main material. Then we need to take care during the installation, and the quality control is very strict. That is the experience that we have in this part of the world.
Yep. In a heap leach pad, is it necessary to place a geotextile between the geomembrane and the overliner?
It's not, but when we have some possibility of that the high loads acting in the overliner and transmitted to the geomembrane, it can be, I mean, a problematic issue and can be some damage or potential damage. In this case, the geotextile is recommended. That's for geomembrane protection, of course. I mean, we have several experience that we did. We proceed as I explained.
Yep. So with the overliner, do you, and even if you have a geotextile, do you perform leak location surveys before or after the overliner to make sure the geomembrane's intact before the ore is placed?
Very interesting and good question. Really, I mean, I had some slides showing that that process, but I mean, I have a very specific time to present this webinar. But it's about 5-7 years ago, maybe a little more. It's mandatory to do two kind of leak detection surveying, which we call the geoelectric. The first one is for the exposed geomembrane, which is done based on the water lamps or spark tests that, of course, everybody knows. After the CQA, of course, and after inspection, the final inspection of the geomembrane. But after the installation of the geomembrane, we need to do again a geoelectrical surveying, in this case by using the dipole method, because more than 70% of the damage that can happen in a geomembrane is during the linear installation.
Yep, right. Next, is pre-curing still a common practice in heap leaching? What special design considerations must be taken?
Pre-curing?
Yes.
Yeah. It's not a common practice. It's depend of the ore, and it is more common in copper operation when we have to add some high concentrated sulfuric acid to cure the ore and to improve the recovery during the normal leaching. Then in that cases, the pre-cure is done in the agglomeration plant, and the material as it is taken to the leach pad. It's not done in the leach pad itself, at least I know. Our experience, the most experience in Peru, we have a gold heap leach pad, and we don't have that process in Gore. We have agglomeration, and maybe that's can be confused with a cure process. But in agglomeration, in gold operation is different. In this case is with cement, and the cement doesn't cause any effect. In copper, the acid sulfuric solution can create some endothermic process, which creates elevation of the temperature, and that can be a problem for the geomembrane, but that also need to be addressed.
Right. Dennis, we just have a minute left. There are probably 20 at least more questions to go here. So we'd like to schedule a follow-up podcast, and I will ask you the rest of these questions. We'll conduct that podcast maybe in the next week or two. So if any of the attendees still have additional questions, please send them in via the webinar survey that will be sent to you shortly after the webinar. And Dennis will address them and the remaining ones here in the follow-up podcast.
That will be my pleasure, Tim.
Thank you, Dennis. I appreciate you signing up for the podcast. But again, there's probably at least 20 questions here. Dennis, could you go to the next slide? Here is Dennis Parra's contact information. If you want to contact him about questions, or you can send them to me or Jen Miller, and we will plug them into our podcast coming up in a week or so. Next slide, Dennis. Our next webinar is a live panel discussion on subgrade preparation and QA/QC procedures for geomembranes. Some of the photos that Dennis showed with subgrade preparation on rock were amazing. So bring your questions to the live panel discussion on December 8th. Next slide, please, Dennis. A lot of information on the FGI website, including we will post Dennis's webinar and a PDF of his slides here shortly under the webinar library. And I'd like to conclude one more. Today's webinar was sponsored by Intertape Polymer Group. And Dennis, thank you so much for squeezing this into your busy schedule and joining us from Lima, Peru. And I look forward to our podcast in a week or so.
Thank you very much, Tim, for the invitation. And it was my pleasure to answer any question that you will have.
Great. Thank you, Dennis. And thank you to everyone for attending. See ya.
Thank you.